So 54, force of 5 newtons causes a 1.35 kilogram book to have an acceleration of 0.76 meters per second squared. What is the force of friction on the book? So first thing we want to do is draw a diagram. So here is my book. It has a force applied to it of 5 newtons. Okay. There is friction acting on it, but it doesn't say how much friction, so I'll just call it FF. There will be gravity pulling down, because there's always gravity pulling down, and there will be a normal force acting up. And then the next thing I need to do is label the direction for the net force. So I'm assuming that we're pushing it forward and accelerating it, not pushing it forward and it's slowing down. So that would tell me that the net force would be to the right. And I'm going to call up the positive direction and right the positive direction. On the test, I tried to be specific and tell you what direction was positive or negative. That may not always be the case, but I try to be consistent with that if I could. So when we're solving these, the first thing you need to do always is figure out the net force. Always got to find the net force first. Before you can do anything else, got to find the net force. Okay? And there's two ways to do that. You can do F net equals ma, which is Newton's second law, or you can do F net equals the sum of the forces. And that just means you add them up. So what I want y'all to do is see if you can figure out how to start this problem. So how would you find the net force first? And once you found the net force, how can you use that to solve for what you're missing? In this case, you're solving for friction. So try that. I'll come around and see if you need help here in a minute. First thing we got to do is find the net force. So I always start by, can I add the forces together? I don't know all the forces, so I can't add them up. I don't know friction, so I can't add friction and the applied because I don't know them both. So that equation's out, which means I got to use F net equals ma. And all I have to do is multiply them. F net is 1.35. A is 0.76. Okay, that gives me a net force of 1.026. It's that simple. Finding the net force is that simple. Just got to multiply the mass and acceleration, or you just add the forces. Okay? Now that I know the net force, now I'm going to use the other equation to figure out what I want. And what I want is the missing force, which is normal. So now I set up this other one. And what I say for that is F net equals all the forces added together. Now, they're only the forces in the direction of motion. And those two forces are 5 plus friction, which I don't know. And that's it. I don't need to add normal. Normal's up and down. Motion's forward. I don't need to add gravity. Gravity's up and down. Motion is forward. So this is what it looks like. F net equals 5 plus force of friction. Well, the net force is 1.026. So just subtract the friction, the 5 over. And you get friction equals negative 3.97. Again, a lot of you are making it harder than you need to. A lot of you are making it harder than you need to. Find the net force first. There's only two ways to find it. And either you're going to know all the forces, or you're going to know A. It will never be anything else. You'll either know A, or you'll know all the forces. Okay? So if I know A, I would use F net equals ma. If I know all the forces, I would use F net equals sum of the forces. Okay? And then once you find the net force, then you use the other one to find what you want. So in this case, I use the other one to find friction. Another option would be use net force to find acceleration, just depending on what it's asking. Okay. Questions on that one?